Two men commit the exact same crime of embezzlement. They share similar backgrounds and have identical criminal records. The first man is sentenced to 117 days in jail. The second man is sentenced to 20 years. When we see a gap in the legal system, we look for a systemic motive. We assume the judge harbored deep-seated racism or penalized the defendant for their social class. We search for a predictable, structural prejudice. But often the root cause completely defies logic. Studies of judicial decisions show that sentences fluctuate based on the outside temperature. Judges grant parole more frequently after a lunch break and rule much more harshly on Mondays if the local football team lost over the weekend. In the 1970s, a federal judge named Marvin Frankel analyzed these wild sentencing disparities and realized the courts weren't functioning as halls of standardized justice. They were operating as an arbitrary lottery. The danger in these outcomes is that they lack a pattern. We cannot easily predict or legislate away a judge's bad mood or a hot afternoon. This disparity is an entirely different, unseen mechanism of human failure. When professionals make decisions, we treat their minds like scientific measuring instruments. We assume two qualified experts analyzing the same data will produce the same measurement. But human instruments are heavily uncalibrated. This invisible variability in professional judgment is called systemic noise. It occurs anytime a group of interchangeable experts, people who should theoretically agree, arrive at wildly different conclusions when handed the exact same problem. Modern society invests billions into identifying and correcting bias, but while we fiercely police systems for predictable prejudices, the sheer volume of random, scattered noise goes entirely ignored. This diagram of 4 shooting targets isolates the mechanics of error. Team A's shots are clustered in the center. They're accurate. Team B's shots hit the bottom left, a systemic bias. Team C's shots are scattered entirely at random, simply noisy. If we look only at the blank backs of the targets, we can no longer tell if A or B is closer to the center, but the scatter of Team C is still incredibly obvious. You do not need to know where the correct answer is to measure the volume of random noise corrupting a system. To see how this mathematical scatter destroys value, look at the internal audits conducted by industry-leading insurance companies. Executives at a Fortune 500 carrier decided to test their underwriters by giving multiple experts the exact same risk file to price. Before the test, the leadership assumed their highly trained staff might vary in their assessments by about 10%. The audit revealed a median variance of 55%. If one underwriter priced a premium at $9,500, a colleague down the hall priced the exact same policy at $16,700. That scatter means the price a client receives depends entirely on which desk their file randomly lands on. This silent lottery was quietly costing the company hundreds of millions of dollars in lost clients and underpriced risks. The professionals making these extreme errors rarely notice them because of a psychological trap called the illusion of agreement. Sharing the same office, jargon, and rules, they assume they view the world exactly as their colleagues do. This false confidence persists even in totally unique, high-stakes crises. During the 2014 Ebola outbreak, leaders had to make singular decisions about border closures and military deployments without any historical precedent to guide them. When a leader makes a choice, the facts align in their mind to create a deep internal feeling of coherence. That feeling signals that the decision is correct, blinding them to the terrifying reality that another equally qualified expert would have chosen differently. To understand why this internal confidence is so costly, we can look at a forecasting department at a retail company called Goodsell, where analysts predict future market share. This animated graph plots the errors of those analysts using a concept developed by mathematician Carl Friedrich Gauss called the mean squared error, or MSE. The MSE is a formula that averages the squares of the measurement errors, meaning a mistake's visual weight grows exponentially the further it strays from the true answer. Notice how the positive and negative errors on the graph don't cancel each other out. Instead, the squared blocks of error compound, stacking up into a single, overwhelming total of error. If a business overcharges one customer by $1,000 and undercharges another by $1,000, their balance sheet might look perfectly correct on average, but in reality, they have committed 2 highly expensive mistakes. The MSE equation defines a precise mathematical law: total error equals bias plus noise. When we apply that math back to the justice system, the stakes become clear. A noisy courtroom where one judge gives 117 days and another gives 20 years ruins human lives just as effectively as a system rigged by prejudice. Society rightfully spends billions of dollars, passes sweeping legislation, and dedicates countless hours to fighting against systemic bias. But as long as we refuse to audit and eliminate the deafening sound of human noise, we will remain blind to the math of our own mistakes. We are only fighting half the war.